right, so we are going to be looking at the 12.8 surface area and volume wrap up quick check. I'm going to go through the problems and talk about all of the answers and work through them, of course. And so you can follow along, double check your work, and if you have questions after that, then please come to a tutorial session to ask about it. All right, so we have first our question one, which is asking about the Bluebell ice cream containers. It says, our container has a cylinder with a diameter of 11 inches and a height of 8. Lupe is scooping out ice cream in spherical scoops with a radius of 1.2. And they would like for us to know how many whole scoops of ice cream Lupe can get out of the container that are, to maximize what they can take out. So we're going to need to find the volume of the cylinder. And for the volume of our cylinder, of course, we take our formula, which is pi r squared times the height. And then we're also going to use the volume of a sphere, which is 4/3 pi r cubed. So we're going to use those two formulas to find our answers. So our cylinder has a diameter of 11, which makes the radius of it 5.5, and it has a height of 8 inches. So for our volume of our cylinder, pi times 5.5 squared times the height, which is 8. And I'm going to multiply that out. I'm going to go ahead and just leave it in terms of pi, 5.5 squared times 8, which gives us 242 pi inches cubed for the ice cream. So this is the total cylinder volume. And then we're going to do the same for the sphere. So 4/3 pi. Our radius is 1.2 cubed. So 1.2 to the power of 3 times 4 divided by 3 gives us 2.304 pi inches cubed. Now, in order to find out how many of these spherical scoops I can get out of the entire cylinder, I'm actually going to divide the two pieces of information. So 242 pi, and we're going to divide by 2.304 pi. Now, those pi's we know are going to cancel out. So 242 divided by 2.304 gives us 105.034. So 105 scoops. I'm not going to give somebody a 0.034 part of a scoop. So that covers our question one of how many scoops we can get. Next, we have question two, which is asking if these are similar. Whoop. How did that happen? Oh, that way. If these are similar or congruent or neither. And we have to justify our answer with mathematical work. So first, I'm going to compare the side lengths. I have 5 centimeters with 10 centimeters. I have 5 centimeters with 10 centimeters again. So I'm just matching up the pieces of information that are in the same place between the two shapes. Oops. There we go. Now, obviously, this is not congruent. 5 centimeters is not equal to 10 centimeters, so congruent is already off the table. In order for it to be similar, there needs to be the same scale factor for each one of these situations. So the scale factor for each one of these needs to be the same to make this true. So if I take into account the 5 centimeters times scale factor equals 10 centimeters, and I divide out that 5 centimeters, my scale factor here is 2. But if I do the same for my 2 centimeters times scale factor equals 1.5 centimeters, and I divide out that 2 centimeters, 1.5 divided by 2 gives me a scale factor of 0.75. So these scale factors do not match, and so it is neither. They are not congruent, they are not similar, so it's neither. Okay, number 3 is asking us to find the surface area of a prism. Our prism has a base that is an equilateral triangle. So we have 2 equilateral triangles at either end. They are all congruent to each other. So remember, for surface area, you've got 2 pieces. You've got the lateral, which is the perimeter times the height of our pyramid. The height of our pyramid is going to be 12. If all 3 sides are congruent, our perimeter is 6 times 3, which is 18. So for lateral, we take 18 for that perimeter times 12, which is 216. And then for total surface area, I'm going to take that lateral plus the area of 2 bases. For our bases, we are going to need to find the area of a triangle. Since this is an equilateral triangle, I can create a altitude, which turns this into a 30, 60, 90 triangle. Across from my 90 degrees is 6. So across from my 30 is going to be 3. And so the altitude, which is the height of my triangle, is going to be 3 root 3. So for the base for one triangle, we're going to take the base, which is 6, times the height, which is 3 root 3, over 2. And we get 9 root 3 for one base. Now I'm going to use 2 bases. So for surface area, I have 216 plus 2 times 9 root 3. 216 plus root 3. And when we type that into the calculator, round to the nearest tenth, you get 247.2, and this is meters squared. We are just doing surface area, so it's just meters squared. Now for number 4, I have 2 solids. One solid has a volume of 70 centimeters cubed. A similar solid has a volume of 1890 cubed. So volume new, or volume old, I should say, is 70. Volume new is 1890. And it wants me to find the surface. It tells me the surface area of the smaller solid is 118. What's the surface area of the larger solid? So I need to find the scale factor in order to do this. So I'm going to multiply by scale factor cubed for volume. I'm going to divide out that 70. So 1890 divided by 70 gives me a scale factor cubed of 27. Now that's scale factor cubed. I need to get scale factor by itself, no cube at all. In order to do that, we take the cube root of both sides, and that gives me a scale factor of 3. 3 to the power of 3 is 27. Now I'm going to be using that scale factor with surface area. And when we do surface area, our scale factor is squared. So I'm going to take old, which is the 118. I'm going to multiply that by scale factor squared. So not 3, but 3 squared to get the new scale factor. So that's 118 times 3 squared, which is 9. So 9 times 118 gives us a surface area of 1,062 centimeters squared. That was a weird looking too. There we go. So you have to find the scale factor by itself from the volume and then square it to use the scale factor for surface area. All right, lastly, question number 5 is asking us to find the surface area of a regular pentagonal pyramid with the base side length of 8 and a slant height of 18 inches. So they give us the slant height, which is nice. We don't have to find the slant height, but we are going to have to find the area of the base, which is a pentagon. Let's see if I can. Boom, 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 boom. Yay, there we go. So there's our pentagon base. It has a side length of 8 inches, and it's a regular, so all 5 sides are congruent. So first I need to find the area of my base. For surface area of a pyramid, we need to take into account slant height, we need to find the area of the base, we need to find lots of pieces of information. So just a reminder of our formula. So for surface area, we're going to take the lateral, which is 1/2 times the perimeter of the base times the slant height. And then for total surface area is the lateral plus the area of the base, which is that pentagon. All right, so we have, for perimeter, it's 5 sides at 8 inches each. So that's going to be 40 inches for our perimeter. And it tells us our slant height is 18 inches. So for lateral, 1/2 times 40 times 18. Which gives us 360 inches squared. And then we need to find the area of our base, because I'm going to use that 360 plus something. So for the area of our base, we're going to need to find the apothem. So from that center point, we are going to create our central angle. This is 5 sides, so 360 divided by 5 is 72. But then we take our apothem, which is like an altitude, and cut that in half. So 72 divided by 2 is 36. So this angle in here is 36 degrees. Now that apothem also cuts in half the side length. So this side of my triangle right here is 4 inches. So I'm going to have to use trig to find that little a, that apothem. So I have the opposite side and the adjacent side. So I'm going to use tangent. Tangent of 36, opposite is 4 over adjacent, which is that little a. Then do a little switcheroo. 4 divided by tangent of 36. Make sure your calculator is in degree mode, which mine is not. There we go. And my apothem is 5.50527688188. And then the area of our base is 1/2 times that apothem times the perimeter. So the perimeter we already found was 40. So 40 times that apothem, save that whole number in your calculator, times 1/2 or divide by 2 is 110.110.553638. So I'm going to add that up here. 0.11055, yada yada. So plus 360 And my final answer for total surface area is 470 rounded to the nearest 10.1 inches squared. All right, so again, go through this with your work, check your steps. Maybe you fudged a number here or there. Maybe you were doing volume instead of surface area. I mean, there's lots of possibilities here. Just go through, check your work, and then ask questions. All right, I will see you later. Bye.